Hey, this is Wes McDermott, and in this quick tip video, we're going to take a look at using the line renderer to animate a line being drawn. So I'm going to go ahead and hit play here, and I'll let you see what's going on. So I'm using the line render here, and you see that we're just drawing a line, but we're also animating that line being drawn. Now, I worked on a project this week where I had to actually do this, and so I came up with a way of doing it, and I thought it was pretty cool, and I just wanted to share it with everyone. So let's take a look at how this was done. Okay, so what I have built here is just a little example scene, and we've got two spheres here, and so let's take a look. This first sphere here, I'm calling this origin, and the second one here, I'm calling destination. And so these are basically going to be like 2 points in space here that we're going to draw the line between. And then these are just simple game objects. As you can see, I have origin selected, and it's just mesh render. It's just nothing. Just what I did was I went to game object, create other sphere, and that's how I got these guys. And then you have the a line renderer here. So what the line renderer is just I went and created an empty game object and just placed that in my scene. And then what I did was I actually added the line renderer component to that. So let's take a look at how I did that. So I went to line renderer, component, effects, and then line renderer. And what that does is it creates the line renderer component. And on here, what I have is things like cast shadow residual. So I actually don't really need any of that stuff on for this guy. But what you need to do is first thing is you need to create a material. And you need to set this material and then apply it to your line renderer. So what I did over here in my projects is I went down to create and I did create material and I got this guy here. So renamed it line renderer, came over to my shader type here. So I'm just going to click the shader kind of preview ball here, and so we can see more about it. And what I did was I just have this particles additive shader. So I came all the way down here to particles and chose the additive shader. And then it asked here, well, it gives me a color tint, so I can actually change this to any color. And I used green here so you could see it. And then for the particle texture, all this guy here is just a simple texture file. And what it is was I think it's a 50 by 50 pixel image in Photoshop and just filled with white. So it's just a square is all it is, and then just drop that texture file right here into the texture slot. And so I have that material. Now if we go back to line render, you can see that that's the line renderer material here. A lot of different things here with line render. It works with probes and things like that. Positions. This is another thing here we want to take a look at. So positions, there's obviously two positions to this line render because it has to have a start point and end point that you can draw the line between. And so if you look at positions, it has two written here, and then we have an element 0 and an element 1. And if you notice, these all say 0, so I'm not actually using this kind of GUI interface here to actually set the positioning for this line draw. I'm actually going to do that via script. And then you can actually go in and change if you want this to be world space or not. So as you can see, that the most important thing with this was added the line renderer, added a material to it. Other than that, I didn't really touch anything else with this. So we've got line renderer, we've got a material, and then we have this draw line script. So then I just place this draw line script on here. And so what we're going to do is take a look at what this draw line script does. And so I'm going to open up MonoDevelop here. And we have MonoDevelop, and let's see if we can't kind of zoom in on this here so you can really see what's going on. And we're just going to go through this line by line. And by default, what I have here is everything is basically commented out. So let's just save this script, and we'll go back. And we should see this guy update here and just kind of blank out. Still showing kind of like my here, let's go back. Oh, here we go. We've got a parsing error in here. That is what is going on. Let's see. I think I commented out something. Yes. Okay, I actually had the update function here. Alright, so let's save this guy again and go back to Unity. That should be fine. Okay, so there we go. So what we did in MonoDevelop, I have everything commented out. So this is just like if I were to have created a new script, and we have our start function, and we have our update function, and nothing else is going on. So all the code's commented out. And here in Unity you can see that, we just have the script applied to our line renderer, and there's no variables or anything. So now we're going to take a look at this guy line by line. So the first thing that we want to do, and I'm using C# to do this, and it's very similar to do the same thing here in JavaScript. It's just a little bit of syntax differences. So first thing we're going to do is I created a couple private variables, and so let's uncomment these guys. So the first one is the private, and I create them private because they're not something that I want to actually expose to the editor. So I create private a line renderer variable here of type line renderer because I want to cache basically the reference to the line renderer that the script's attached to. Then next thing we're going to do is we have a private float called a counter, and we're going to use that as an incrementer element as we start to draw a line. You'll see how that works here in just a bit. And then we have another private variable called distance, and I'll explain how that's going. So these are three private variables that are not going to show up in our editor that we're going to use throughout our code. And so the next thing that we have is our publics, or excuse me, our public variables. So first thing, we have a public, transform, and origin. So this is basically a space, a vector, a space in the 3D viewport that we're going to use as our origin to begin drawing our line. And then we have another one called destination. So we have an origin point, a destination point, and those guys are of type transform because we actually want to, get the actual transform. So again, if we go back to Unity, transform here being we want to actually be able to look at the position of the x, y, and z of that transform. So that's why these guys are of type transform. And then finally, we have another public variable here called float. It's a float type, and it's called line draw speed. And this is going to control how quickly the line is actually drawn. So we can speed that up or slow that down if we want to. And so at this point, now if I go ahead and save this script and we go back over to Unity, and we update this guy, you can see that we now have these variables showing up here in our editor. And so what we need to do is we need to set our origin point. So what I'm going to do is I'm going to come over to the hierarchy here. I'm going to grab my origin sphere, and what I'm going to do is drag that onto that script. So again, let's just make sure that the line renderer is selected. I'm going to click the left click on the origin, just drag and drop that guy and set that transform right here. So you can see that the origin is set to the transform. I'm basically getting the transform of that sphere. Let's do the same thing for the destination. So I'm going to come up and grab hold of the destination, drag and drop that here on the transform, and now you can see that we've set those public variables here. So we've got an origin. So if I click this, you can see the origin sphere is highlighted. If I click destination, you can see the destination guy. So here's our 2 points. And then we've got our line draw speed, and we'll go ahead and just leave this at 6 right now. So let's jump back over to MonoDevelop and continue on checking out what this script does. So the next thing that we want to do right here in our start function is we want to cache the line renderer. And so whenever you're working with any type of component inside of Unity in your script, you always want to try to cache that component. You don't ever want to do like get component or lookups inside of an update function or something that's happening per frame because that's going to be expensive. And so you want to cache this stuff whenever possible. So we're going to uncomment this line. And so what we're doing is we're taking our line render. Now remember, our line render here was a private variable that we kind of set at the very beginning, that we declared at the very beginning. And so we've got our line render, and we're going to equal that to the get component of type line renderer. Now, how does this actually work? Okay, so this is saying I want to go and get the component line renderer. Now, the reason why we can write it this way is because this component, this line render component, actually exists on the game object the script is attached to. So if we go back over to Unity, you can see that we have this draw line script. Well, right above it, right here, as part of this game object, you can see that the line render component is on this game object as well. So that means that in our start function, we can simply use this get component to actually cache that line renderer. So now we can call functions and call things on the line renderer. And that's what we're going to do here next. So the first thing that I did was on the line renderer, you've got a couple things that you can do, and so one of the things is we can set position on this guy. So real quick, let's check this out. So if I go ahead and just say line renderer dot, and you can see that our code syntax starts coming up, our IntelliSense here, that letting us know what can we work with this guy, and you can see that there's a couple things we can do to this. Let me see if I can. Here we go. So we can do a couple things like we can set the colors of the line, we can set position, we can set the vertex count, we can set the width of the line, things like that. So that's what we're actually working with here. So in the case of this guy, what we want to do is we want to set the position. Now remember, if we go back over to Unity and we check out our line renderer, right here we have 2 elements. So remember, we've got this positions here, and underneath positions we've got 2 elements. So it's set to 2, element 0 and element 1. Now this element 0 is basically talking about the starting point of the line, and element 1 is talking about the end of the line. And as you recall, if we kind of drop these guys down, you can see that they have a position, so it's a vector of x, y, z, and it's all 0. So it means, it's just 0, 0, 0. None of that's being set right here into the line renderer component in the editor, but it has these two elements here. And so if we look at set position 0, that's talking about this element 0 right here. And if we do look at set position 1, that's talking about element 1. So it's basically using array syntax. So if we come back over to MonoDevelop, you can see that I'm saying line renderer. I want to set the position. Now, what position do we want to set? We want to set the origin or the first point of that line, so that's why we're using the 0 here. And then what we're going to do is feed that in a vector. So we're going to say origin.position. Now, if you recall, origin is a transform. And so if we just we'll go ahead and just get rid of that, and if I say dot, I can actually start to type in position. You can see that position is going to give me that XYZ values from the transform. So we're basically setting that vector based off the transform's position. And so that's why we put that in here. So that's basically saying, okay, line renderer, your very first point or the starting point of this line, you're going to be at the origin, that game object, which is our first sphere, its position. So go grab the spheres X, Y, Z and use that. Then we're going to come over here, we're going to uncomment the next line, which is line renderer.setWidth, and I've got just a couple floats in here, so it's 0.45, 0.45. And this is going to be the actual width of the line, like how thick it is, basically. And what you have here is a start and end. So at the very beginning, how thick is it, and at the very end, how thick is it? And it's kind of cool that you can actually change this. You could say you can make your line a little thicker at the beginning and have it taper down as it ends, things like that. But in this case, I left them both at 0.45. And you can change this, like I said, you can change the width to the start and end. Okay, and then the next thing that we have here is this distance. And so I'm going to set this distance. Now, if we go up at the top, that was a float value. And so we're going to need this distance here a little bit later on in our update function. But I went on ahead and just calculated this at the start. And so what I needed to do was I needed to see how far apart let's go back over to Unity. What I needed to do in order to draw my line, so like to have the line actually animate. Now, I don't need this to actually just draw the line in line render. If I wanted to draw it through code, all I had to do really is just say line render set position 0, give it a position, line render set position 1, and then give it a new position and it'll draw the line. But like I said before, like what we want to do is we want to actually animate this line. We don't want it just to hit play and have it boom just be there. We want to animate it. So one of the things that we need to do is we need to grab a distance. So we need to know how far, how long are we going to draw this line. And so what I do is I'm saying, well, we've got a point here and we've got a point here and we're going to draw a line. So what we need to do is again know how long that line is. And there's actually a little helper function from the vector3 class part of Unity called .distance. And what that does is it takes a transform, basically an XYZ vector from one position here, and then it takes takes one or two positions here. So you got the first position and the second position, and what it'll do is it'll return a float value, which will basically give you the length of of those two positions, or the distance. So how long is that? And so that's why I call here the distance. So basically I'm just feeding in, I want to know how long or what the distance is between these 2 points. How long will this line be? So I feed it, the origin and the distance using a vector3 helper class, and now I get a distance value, which is a float. So again, if we kind of come to here to the top, you can see it's a float type. And that's going to take care of all of our kind of startup stuff. So again, just to recap real quick, we got the component, we set the first position line, we set the width of our line, and then we calculated a distance between our 2 points. So that's what we have. Now, the next thing that we do is we're going to start working with the actual update function. So in order to actually draw the line, what we needed to do was we needed to first be able to set up a counter, or basically we want to say like, well, here, let me explain it this way. This will be a little bit better. We'll comment this out as we go. So first thing that we want to do is we basically want to set 2 positions here. So let's uncomment these 2 lines first. So we'll just take this out one at a time. So we take a vector 3 of point A and a vector 3 point B. So again, a vector 3 being x, y, z. So it's a positional data of 2 points in space. And point A is origin dot position and point B is destination dot position. So again, back to Unity, this is point A, this is point B. So we basically are just saying we know what those values are in x, y, z. So we know what their coordinates are. And then what we want to do is we want to be able to draw a line, but not only do we need to draw the line, but we're going to be animating that line drawn. So imagine if you take a look, if you got a line from point A to point B and it gets drawn, we want to be able to actually say, let's see if we go ahead and just run this real quick. Oh, it's not going to work because I have things commented out. Let's do this. Let's say that, I'll tell you what, let's try this here. Okay, so I have this cool little utility here. Let's me draw on the desktop. I've been waiting to use this for a while, so here's my big chance. Okay, so we have 2 points, and so we've got a point A here, and we've got a point B, and we know that we're going to be drawing a line from point A to point B like this. Okay, and so what we want to do is we want to animate this line. So imagine, if we take a look at how this, if we take a look at like a frame-based animation, we could say like, well, on frame 1, we're going to be this far. On frame 2, we're going to be this far. On frame 3, we're going to be this far, and so on and so forth until we actually get to the end of the line. So think about each one of these little tick marks here as a frame. So 1, 2, 3, 4, 5, and so on. And so what we're going to do is, let's go back here to Mono Develop and start to comment out this line so we can work with this guy. Let's bring this back. Okay, so first thing we're going to do is we're going to take this vector 3 and we're going to create a new position. Okay, and we're going to call this point along a line. And what we need to do is we need to basically figure out, as this line goes, we need to figure out, okay, at a certain point in the update, where is it, or the update, remember update's happening, it's called once per frame. So on one frame, we want to know where a point is. On the second frame, we want to know where the point is. And all we're going to do is update. We're going to get what that point value is, and then we're going to feed this over to our line render set position, which you can see down here, and I will uncomment that in a second. So we're going to, each frame, we're going to calculate a new position on that line, and then we're going to feed that new position to the set position of the line render 1. So remember, that's that second element that we're going to set that line to. And the way we do that, and this was kind of tough because I'm not like a mathematician by no means, so I always have a hard time with this stuff. So I had to actually kind of look around online. I knew that, I had the distance between, I knew how long the line was, I knew where the line was, and I knew that I needed to be able to break the line down into a couple different points. So what I ended up finding was a way to like, and see, once you have all that stuff, it was, I knew that could be done. So I just started searching online and I figured out that, it was actually pretty easily done. And so what I needed to do, here, let's go back over to Mono Develop here. So what I needed to do was I came up with this vector 3 point along a line. And so I've got this little note here. And so here's how you do this. So the first thing you do is you get a unit vector, okay, in the desired direction that the line's moving. So every line moves in a direction. So that's, you can either go, one way or the other on the line. And then you want to multiply that by the length and then add the starting point to it. Okay, so this is the equation here. Now, again, I told you I didn't come up with this equation on my own. I just start doing searching online, and that's how I do a lot of this kind of math stuff, because like I said, I'm no mathematician. But here's the equation that you use. So first thing that we do, let's take a look at this. We've got, the first thing we want to do is we want to get this unit vector in a desired direction. So how do we do that? That's done right here. So to do that, we take point B, which is our end, and we subtract it from point A, which is our beginning, and then we do and so that basically gives us a direction, okay? But we want to get the unit vector of that, so that's why we do a vector 3 dot normalize of these two guys. So this right here, vector 3 dot normalize, point B minus point A, is basically going to give us this unit vector in the desired direction, okay? Then we multiply that by the desired length. So right over here that's what x is. So we don't know the length. So if we go back to this line here and we're talking about, this is our point A, this is our end point, what's the length of this, where are we going to be going with this? The length, or this x here, is going to be, where we are in the line per frame. So remember, we want this value to change so that as that value changes, we can feed it to the line, which will thus give us the illusion of animating that line. So we're going to come back and say we want to take x, which is again going to be our desired length, and we're going to multiply that by what we've been doing, and then we're going to add the starting point to that. So the starting point just being this guy right here, that origin position. So how are we going to get x? That's our next part of that. So x happens is it needs to be a value that's changing over time, because it's going to be that length is going to change. Now again, when I say that length, think about the line. So the line's going to grow. So if you start on one frame, the line's this way. Then as the frames keep progressing, the line's going to get longer and longer and longer. So our length is going to change as we progress. So what we're going to do is we're going to use this. So let's uncomment this guy, and this is going to be x. So here's x. We don't know what x is, so typically in algebra you do an x there. And so float x equals, now we're going to use the mathf.lerp function. Now what the lerp does is just basically a linear interpolation between two values based off some type of time or whatever. So what I did here was I said, well, we're going to start at 0 and we're going to go to this distance here. So again, if we scroll up to the top, you can see that that's where our distance comes in. Well, we know what the distance is going to be because we're drawing the line between these two spheres. So eventually we know how long this line is going to be. Okay? All we want to do is just animate that distance between the two lines. So we know the overall structure of the line. We know how long it is. And that's how we figure that out, by using that vector3.distance. Again, it's another convenience function, part of Unity. We took the origin position and the destination position, and the vector3 just threw back to us a nice float value that we could use. So if we scroll back down to this, we've got the float x. We do a lerp between 0, which is obviously 0 is where we're going to start, and the distance. Okay, so now we've got the beginning and the end, or how long we're going to go here, and then we've got this counter value. So the counter, that distance is going to keep changing, okay, based off this counter. So we're going to lerp between these two guys. So what MathLerp's going to do is a linear interpolation. It's going to feed us back a float that's going to be between this value and this value. Okay, so it's either going to be between 0 and however long our line is going to be, and it's going to do that based off this counter. So remember, again, down here in our point along the line, we're going to multiply that by our desired length. So again, we know what our length is, and we're just multiplying that. So what really makes this happen, so we've got all this together. We've got the equation that basically helps us here. We've got our positions. We've got a value that's going to be changing, but we need to actually introduce an actual changing variable. And that's where we come in with this guy right here. So the next line that we do, and I'm going to uncomment this guy, which is we have this counter variable. So again, if I scroll back up to the top, remember we have this private float called counter. And it's not, it's not initialized to anything, so it's basically 0 to start with. And we come down and we just basically increment this guy. So think about counter. Well, it's counter. It's an incrementer. It's basically going to be changing. And so we basically say we want this guy to plus equals. So that's the same thing, or it's basically shorthand for saying, hey, counter equals counter plus something else. So you're basically adding to itself each frame. So plus equals 0.1f. So a tenth is what we're basically going for there. So 0.1 f. So if you think about that in 10, so if you think about if the line is going from 0 to 100, we're going 10, 20, 30, 40, all the way up here. We'll bring our cool line back up here. So again, think about this is 0.1, this will be 0.2, this will be 0.3, this will be 0.4, and so on, all the way up until we get to the end of the line. Now, the end of the line in our case, depending on how long this guy ends up being, could be 0.20 or 0.30 or whatever. It could be who knows what it is. It doesn't matter because we're dynamically finding out the length of that by setting it right here at the very beginning. Remember, we're getting our distance, which is our vector3 distance. So that doesn't really matter. That's going to be calculated for us dynamically. So then what we're doing is we're saying, okay, so plus equals 0.1. So 0.1, keep adding 0.1 to that counter. So that counter is going to be changing every single frame. And so that's going to be basically doing a lerp between 0 and whatever this number is. So let's say that distance is 20. Okay, so if we look at this and we just type in 20, say that distance, scrolled here. Let's say that distance, and that distance again, remember, is the distance between these 2 points here in space, which again is figured out right here, 0 and 20. that counter, this lerp, is basically going to give us a value between 0 and 20. So even if that counter keeps moving forward, and it's going to keep counting, keep counting, keep counting, and all that stuff, it's never, this float x is never going to be more than whatever this second value is. So it'll never be more than 20. Okay, so we want to actually go back and just change that to that distance, because again, that's letting us dynamically figure out what that distance is. Okay, so our counter. How's our counter moving here? Again, remember we're doing this plus equals, so we're doing an incrementer here of 0.1f. That's how much it's changing each frame, by just 0.1, 0.1, 0.1. And then to slow that down, I divide that by a line draw speed. And again, that's just a value here that's a public variable, line draw 6f. So in our editor, so if we go back to Unity and we look at our editor for this guy, so let's select the line renderer, and you can see that our line draw, we can actually change this. So if we want this to go slower, we can maybe change this to 10. It's going to draw the line slower. If we want to go faster, we just drop it down maybe 2, and it draws kind of fast. So we're just dividing that value there by our line draw speed, and that's just, again, to control the speed of the line. Okay, so that's happening here in our update function. And so we've got the incrementer basically is giving us a value, so it's going 0.1, 0.1, 0.1, and it just keeps moving up. So it starts like this. It goes 0.1, 0.2, 0.3, 0.4, and it keeps moving up. Again, that's being modulated by this line draw speed since we're dividing it. This counter is then being fed into this math lerp. So we're going to do a linear interpolation between 0 and whatever our distance is based off what this counter value is. So again, we're adding 0.1 to each frame, and we're counting from 0 to whatever our distance is based off this counter, and that's being placed into this x. Then we've got a point A and point B destination, and then we feed in our little algorithm here, or our little equation here, that's going to help us figure out where we are on that line per frame. So remember, again, if we go back to our line here, we're going to, this code, this line right here is actually going to help us figure out, we know our distance. So here's our distance. We know what that is. And this is going to help us figure out where we are on this line. So each one of these little tick marks per frame. And we're going to keep growing that. And once we get those values, we're going to set those position in the end. So that's what we're doing here. And then finally, we're going to take point along a line. So it's going to be a new XYZ position, so vector 3. And then finally what we're going to do is we're going to say, hey, line renderer, I want to finally set the position of 1. So remember, 0 is the first element, 1 is the second element, which is the end of our line. And we're going to set that by point along a line. And so point along a line is changing. It's increasing every single frame because we're actually multiplying it by a distance. And we're figuring out where we want to go by using this equation, and that set point position is actually changing. So there's how we're actually putting everything together. And then finally what we want to do is we want to cap this guy. So, if counter, as long as counter is less than the distance, we want this update function to run. Now, even if I didn't have this if statement in here, everything would still work, okay? But, I like to kind of like, if I don't need to constantly be running through this code, in an update function, I kind of like, basically it's like I think about shutting it off. So by doing that, I'm just going to go ahead and put like a little check in here. So that's what I'm going to uncomment this if statement. So as we run through this update here, we can say if counter is less than the distance, then go ahead and calculate our line. If when the counter is not, if it's not less than the distance, then let's not run this code anymore. There's no use in constantly running through that code. And so that's why I put this little check in here. So now we'll go ahead and save this guy, and we'll go back to Unity. And again, as you see, as we start to hit the play button here, we start to draw a line. Now notice the line's going much slower that time. That's because we put 10 on this. Let's go ahead and change this to 2. And now we'll hit, and you can see that line goes a little faster. We can even make this go a lot. Let's just maybe take this down to 0.75, and we'll hit play on this guy. And you can see, boom, our line draws even faster. So again, maybe we'll take this up to 12. And now our line is going to draw a whole lot slower. But you can see how this is actually working. So that's pretty much going to cover us here for this quick tip. Again, this was something that I had to do on a project this week. It took me a little bit to figure it out. I had to, again, find that little equation on how that was going to work. But it ended up being pretty cool, and I thought it was kind of interesting, so I definitely wanted to share it here on unitycookie.com. So stay tuned. Keep coming and checking the site for more quick tips. Thanks a lot.